The Raspberry Pi is a low-cost, credit card-sized computer that plugs into a computer monitor or TV and uses a standard keyboard and mouse. It is a capable little device that enables people of all ages to explore computing and learn how to program in language, such as Python. It's capable of doing everything you expect a desktop computer to do, such as browsing the internet and playing high-definition videos. In this project, we are developing a material handling system by integrating various sensors and actuators with the aid of programmable logic controller (PLC) and also Raspberry Pi. So, the objective of this project is to develop a material handling system by integrating various sensor and actuator system using the Raspberry Pi microcontroller. To complete the project, we need to construct a material handling system that consists of conveyor belt, pneumatic acting cylinders, electrical motor, sensors, and many more devices that imitates the working principle of material handling system in the industries.
Explain about the design of the box. As you know, the size of the box must be suited to the size of conveyor belts. So it can go through the sensor that located above the conveyor belt. So the front box, as you can see, we put the transparent sheet so that we can see the ball drop to the container and can count how many balls there has been dropped. By that we can check the number of the ball drop are same or not with the reprogramming. So from the tops, there is a red stick, and at the middle of the red stick has illumination that we use to detect the sensor, for the sensor to detect X. The position of the red sheet must be parallel to the sensor. This one we assume as a sensor, and the illumination sheet need to be near to the sensor, so we will get more accurate detects. The detect will be more accurate. So now we go to inside the box. Inside the box we have an inclined plane, which this plane is used to easy the observation by direct the ball to the front container. We set the angle about 60 degrees to prevent the ball bounce back from the container.
This is the external circuit of our twin bond project. The positive terminal of power supply is connected to the connecting probe so that more wires can be connected to it, and the switch is connected in between the positive terminal to the connecting probe so that it is able to control the main current flow in this circuit. For sensors, brown color wires are connected to the positive terminal and blue color wires are connected to the negative terminal of the power supply. For the black color wires, we connected it to a series of resistors, and I take out the circuit, it looks like this. The black color wire of sensor A is connected to a 10 kilo ohm, 2.2 kilo ohm, and 1 kilo ohm resistor and back to the ground. And we use a jumper to connect it in parallel with a total values of 3.2 kilo ohm resistor to the Raspberry Pi GPIO pin X, and then back to the ground. We use the concept of potential divider to make sure that the voltage from here to here is in between 3 volt to 3.3 volt. As too high voltage will cause a damage to the Raspberry Pi, and too low voltage will cause a fluctuation result, shows by the sensor. And then sensor B, we connected it to a Raspberry Pi GPIO pin 7. For relays, we connected the red color wire to the positive terminal, and the black color wire of relay A is connected to GPIO pin 11, and for relay B, we connected it to GPIO pin 10. When relay A is on, the motor is started to run, and when relay B is on, it will run the platform in a counterclockwise direction. When relay B is off, it will run the platform in a clockwise direction. So for humidity sensor, the first leg is connected to 3.3 volts in the Raspberry Pi, and the second one is connected to GPIO pin X, and the last leg is connected to a ground pin of Raspberry Pi. In between the 3.3 volt and the pin, we connected a 4.7 kilo ohm resistor in parallel with it. Then for the solenoid, the first one, I label it as 1, 2, 3, 4. So for the first cylinder, it is a single acting valve, and the red color wire of it is connected to the positive terminal, and the black color wire is connected to the GPIO pin 27. The rest of 3 are double acting valves, and the red color wires of them are connected to the power supply in positive terminal, and the black color wire of the cylinder 2 is connected to GPIO pin 17, and the cylinder 3 is connected to GPIO pin 22, and the fourth cylinder is connected to the GPIO pin 9. So, from the Raspberry Pi, a ground pin is connected to the negative terminal of power supply, and so on the interface circuit board also, the ground pin is connected to the negative terminal of the power supply. So basically, this is the layout of the interface circuit board. Ground, ground, ground solenoid pin. Then, this is the single acting valve with spring return, and this one is the double acting valve with pressure supply. So before activation, the 4 valves are in this position. The pressure supply to here, so that the pressure here is higher than here. So the piston is moving up. And then from here, pressure supply to this position, so the pressure here is higher than here. That's why the piston moving up also. So when the valve is activated, now the pressure here is flow back to the vent. So the spring now will return the piston inward. And for this one, pressure will supply here. So now the pressure here is higher than here, and the pressure here will return back to the vent. So now the piston is moving in. So basically, this is the working principle of the 4 solenoid in this ping-pong project.
So at first, we need to import Raspberry Pi GPIO as GPIO and also the HT22 temperature and humidity sensor. And after that, from system we import exit and also import time. After that, we assign these different components into different GPIO pins. After that, we start to set the mode of GPIO as BCM and also set up different parts of the component, which includes cylinder and also relay and also the sensor. After that, we read this EHT22 temperature and humidity sensor, and also we will print out the humidity and temperature at the surrounding. And also we have given this time slip of 10 seconds to let the sensors to calibrate. So initially, we set this cylinder 1, 2, 3, 4 and also relay A and B as high, which means the pneumatic cylinder will be extended out. After that, we'll be going through a looping program. So if input sensor A equals to 0, which means there's a metal sent at sensor A, so the relay A and B will become low, which means the motor, the conveyor line will be stopped, and also the cylinder 2 will be low, which means it contracts inside and also extends out back again, followed by cylinder 1. So there's 2 repetition of this program, which means there will be 2 balls falling down. After that, followed by relay A and relay B with GPIO high, which means the conveyor line will start to move again. So for sensor B, it's exactly the same thing, just that it applies on different cylinder, which are cylinder 3 and also cylinder 4. And for this, relay A GPIO high and relay B GPIO low, it means the conveyor line will be moving at an opposite direction. So else print nothing except from keyboard interrupt, which means if there's nothing sent from the sensor, it will print nothing until except from stop the program by interrupting the keyboard. That's all. Thank you.
Okay, as a conclusion for this project, material handling system was developed by integrating various sensor and actuation systems using a Raspberry Pi microcontroller. The system was designed to take 8 ping pong balls inside the container. The ball were being fed by 2 feeders with sensor on each feeder to detect the container present. The feeder consists of 2 pneumatic cylinders to load and release a ball at a time. The cylinder in-stroke and outstroke were controlled by solenoid valve. The solenoid valve were connected to Pi's GPIO pins and were controlled with the Python programming sequence. The container movement was controlled through the rotation of the AC motor that connected to the relay A and also relay B. The sequence of the component was set through the Python code coded through a Raspberry Pi microcontroller function with the peripheral devices to run the module.